So today I will be telling y'all about the genetic markers discovered for the guarding behavior seen in Apis mellifera. So to begin with, Apis mellifera, also known as honeybees, are the primary producers of honey. This is where all the honey from the stores that you get will come from. They also pollinate 80% of flowering plants in the world, which makes them extremely necessary for agriculture, as well as just the ecosystem in general. In each colony, there are three castes. You have the queen. She will be the mother of the entire colony. So she will mate once in her lifetime and then produce all the eggs that will become all the other bees within the colony. The drones are the males. Their only job is to mate with the queen. So you have relatively few, about a few hundred up to maybe 1,000, and they will only live during the spring and summer. The workers are also females, but they do not reproduce at all. They're the primary worker. They do everything else in the hive other than reproduce. So you end up with tens of thousands per colony. And these are most likely the ones that you will see in everyday life as you walk around outside. So the workers exhibit temporal polytheism. This means that as they get older, they will change the jobs that they fulfill. So, for example, when they're first born, their job is to clean out their cell that they were born in or hatched in. From there, they will go on to nursing, taking care of the other larvae, and cleaning, keeping the hive functional. As they get a little bit older, they'll move on to construction maintenance, where they are building new wax comb as they produce wax. And then as they get a little bit older, they move further from the comb itself and towards the entrance, and they will start collecting food from the foragers and bringing it back and storing it in cells on the comb. And then the last job that they will exhibit is foraging, and that's where they go out and find flowers to collect nectar and pollen. After that, they die. So, in that intermediary phase between food storage and foraging, while they're in that area in front of the nest and in the entrance, some, but not all of the bees will exhibit these specialized tasks. These are guarding or protecting the hive, hygienic behavior, which involves cleaning, making sure there's no bacteria, trapping any parasites or any other bugs that get in that aren't supposed to be in there. And then along with that, there's undertaking. These bees will take any of the dead or dying from the hive outside of it so they cannot infect the rest of the hive with whatever they had. And as they decompose, they don't expose the hive to anything dangerous. So, guarding behavior, as seen in this image, section A, most of the time they're just standing at the entrance with their two front legs held up and their antennas sticking out. So they are looking for incoming bees so that they can check and make sure that they're at the right hive, make sure they have the right pheromones on them. So this includes looking for threats. So any bees that are not of the hive and anything that is not a bee trying to enter the hive. And if they do find a foreign entity trying to enter, they will release alarm pheromones, attracting more bees to this aggressor or trespasser. And then this will cause the bees to sting whatever is endangering the hive. And I put an asterisk there because not all the guards will sting. Typically, the older bees are going to be stinging the threat because stinging kills the bee. It removes part of their organs and thus they die. So this is usually done by the older bees who do not have much time left, allowing the younger bees to live on and continue on in their tasks. So, what genes are involved with this guarding behavior? There have been three sections of the genome that researchers have identified. These are sting 1, sting 2, and sting 3. And while their name is sting, they do also involve guarding behavior as well as stinging behavior. So through this research, they've bred bees based upon a defensive background, so coming from hives that act more aggressively, and a gentle background, or back cross in this case, where the bees do not react as harshly or as aggressively to intruders. So what the back cross means is that they have selectively bred different bees to show these traits. So they took several different defensive hives, bred them together to create an extra defensive hive, and the same thing with the gentle hives. So what you see here are the genes located in sting 1, sting 2, and sting 3. And you can look at these numbers. I'll explain it so you don't have to try and read all of them. The bees in the defensive colonies were far more aggressive, reacted to threats far more often than those of the gentle background. Furthermore, those that were of a mixed breed, a hybrid between the two, also showed increased aggressive behavior compared to the gentle group, but not as much as the defensive group. And one thing that researchers have noticed is Africanized bees, which is a subspecies within Apis mellifera. These Africanized honeybees show increased amounts of those genes and increased guarding and defensive behaviors versus the European variety, which are much more gentle. And so this research was done basically the same way the last one was, but rather than looking at the behaviors of the hives, they were looking at the ancestry of the hives. So the Africanized versus the European genetics. And they focused on this one marker, N4.245, which distinguished the Africanized from the European. And what they found was that the Africanized showed those higher levels of defensive behavior versus the European, which confirmed the theory that Africanized show more aggressive behaviors. So why does this matter? Well, these genes mean that there is a genetic factor. It's not a random thing or hive specific. It is a genetic component that will affect all bees in their guarding behaviors. Why would this matter? Because this favors certain bees to be in certain places. For beekeepers, if they're in an area with many predators of bees, this allows them to breed hives that can defend themselves more easily and are thus less dependent on the beekeeper for protection. Alternatively, if there's not a lot of predators, or for researchers who have to handle the bees very often, they can also breed them to be more gentle, and so they are less likely to react and harm the beekeepers or the researchers as they're handling them. And those are my references.